This is video I19, and we're going to deal with summations. And so maybe we'll start today with just a quick review of sigma. So this will be section 5.2, and today or for this video, we'll just do sigma notation, something that we studied first semester. And then the big thing will be the videos that follow this one will be limits of finite sums. A really important concept. All right, but anyway, so with sigma, it just means a summation. We're adding the terms of a sequence. We have an index. You can use whatever letter you want, like I equals, and you can start at any value you want to, but typically it's starting at 1. You have the term, the value of I of the last term of your series, and then you have a formula for the kth term. So this would be an explicit formula. This part right here. And you know what? I'm sorry. I don't know why I put k there. I'm using I as my index. A sub I. The explicit formula for the ith term of a sequence. Okay, and we're just going to take all of those terms of the sequence and add them up, and we get a series. The series would just be the value of that summation right there. And we've worked with that. Some rules that we have to remember. If you have terms in your summation, you can split that up into 2 separate summations. And here I'm using an index of k, b sub k. If you have a constant, gosh, terrible lad. If you have a constant times every single term in the sequence, you can pull the constant out. Basically, you're distributing it to every term without that. And then some more properties that you've already studied and hopefully kind of have a sense of. If you have a constant sequence, think about what that's saying. Okay, you're adding up n of these constants. And so it would just be n times that constant. In other words, if you have k equals 1 to 5 of 3, if you wanted to, you could evaluate this by saying my first term is 3, and k is 2, 3, 4, and 5, and so it's just 5 times that constant. And we studied these too. So here, this is what I would call a linear series, where your first term is 1, then 2, then 3, then 4, all the way up to the last term. And we had different formulas for this, but this is a fine one too. All the way up to the nth term, whatever n is. Okay, so this is a linear, this is a quadratic. So here, think about what this is. This is 1 squared plus 2 squared plus 3 squared, and so forth. And this is perhaps the most difficult one to remember, but recall, and I think you're given these in IB, but recall the 6 on the bottom, that helps. And then, just because I have room, let's do the cubic one. Hopefully you can see this. Okay, the cubic one is actually very easy to memorize because it's this one squared. And if you want to see what this really represents, this is 1 cubed plus 2 cubed plus 3 cubed, all the way up, and I should have put n squared there, all the way up, and maybe it would be good to say, okay, n minus 1 squared, or cubed, plus n cubed. And so this allows us to do problems like this. This is problem 1. I need new lead. Oh my gosh. Evaluate from k equals 1 to 30. K cubed. I have on my paper minus, so we'll put minus here. Minus k squared plus 3k minus 2, using the simplifying properties. I would call these two right here the simplifying properties. Yeah, I can break this up into 4 separate, you don't really have to write all this, but into 4 separate series. And then I can also use the other simplifying property and pull that constant out front. That's a k. Okay, and then use the properties on here where the n is 30. And so this first one would be 30 times 31 divided by 2 all squared. The second one, now n is still 30, we're using the quadratic, so it's 30 times 31 times 2 times 30 plus 1. And subtract it there. Then I can't forget I have the 3 here, and this is a linear series. And so it looks just like that one. And finally, a constant. We have 30 of these 2's. And we should get, I think I've written this down somewhere, unless I've written something incorrectly. And don't forget, you can do this on your calculator. It's sometimes very useful. The sigma, the easiest way to get to there is alpha window, and it is number 2. So you could have just typed this in. Maybe that's good practice. Go ahead and do that. Make sure you do get that answer. Right, so by the end of this section, we'll be able to do 1 through 11. Look through those and see if you can do any, but we have kind of a much more difficult lesson next time.